Hello students, okay, welcome to economics session. Yes, in the previous session you learned what was the equation for linear demand curve. What was the equation for linear demand curve? Now in this session let us derive what is the equation for elasticity along a linear demand curve. Okay, for a linear demand curve, when elasticity is applied, what will be the equation? Okay, so you know that guys, Q equals A minus BP, where minus B equals delta Q divided by delta P. And when I was explaining, okay, the elasticity of demand, we arrived at the equation that is delta Q divided by delta P into P divided by Q. Right? Sorry, it is delta Q divided by Q into P divided by delta P. We arrived at this equation, guys. Now, if I apply this to this equation, if I substitute this to this equation, so I can rearrange this and write as delta Q divided by delta P into P divided by Q. Is getting my point? I just rearrange this and wrote delta Q divided by delta P and P divided by Q. That's all. Okay. So we know that delta Q divided by delta P equals minus P. Equals minus P. So I'll substitute it as minus P into P divided by Q, which is nothing but minus P divided by Q. P divided by Q. Yes? So again you know that Q equals A minus BP. Q equals A minus BP. So the elasticity, guys, I substituted the actual equation, that is the equation of linear demand curve, to the equation of elasticity of a demand curve. Okay, this elasticity of demand, I have merged both this equation and arrived at minus B into P divided by Q. So elasticity of demand can be written as, okay, minus BP divided by Q is nothing but A minus BP. I can substitute it as A minus BP. Okay guys, it is A minus BP. So ED is nothing but minus I am taking on this side, which is BP divided by A minus BP. Is A minus BP. As this is the equation of elasticity of demand along a linear demand curve. So the equation for demand curve was only, linear demand curve was only Q equals A minus P, but the equation for elasticity of demand along a linear demand curve is minus BP divided by A minus BP. Okay students, we derived that elasticity of demand along a linear demand curve equation is minus BP divided by A minus BP. Guys, if you observe this graph carefully, okay, if you observe this graph carefully, so here on the x-axis we have quantity and y-axis we have the price. So this is x-axis and this is y-axis. So you know that A is the maximum limit function. You know that A is the maximum limit function. So A divided by B is nothing but these are two are constant. So A is the maximum limit function. When price is 0, what is the quantity? That is known as A, and B is the changing quantity divided by changing price that I have learned. So I have not taken minus B because minus B I have shifted aside here. Okay, this is aside bari B tagone. Okay. So here it is A divided by B, and this is A divided, this is another price, that is A divided by 2B, and this is 0. Okay, the price 0. So guys, they are telling the elasticity along a linear demand curve. Okay, the elasticity along a linear demand curve has certain conditions. Okay, they are different at different points. Okay, they are different at different points. So when the price is 0, they are telling elasticity of demand is 0. When the price is 0, they are telling elasticity of demand is 0. Okay. When the price is A divided by 2B, when the price is A divided by 2B, they are telling the elasticity of demand is equal to 1, which is known as unitary elastic. When it is equal to 1, we will known as it is unitary elastic. Okay, and they're telling when the price is above 0 and less than A divided by 2B, elasticity of demand will be less than 1. Okay, it will be less than 1, which is called as inelastic. Okay, this is called as inelastic. To learn this. Next one, they are telling any point above the price line. Okay, any point above the price line, the elasticity of demand will be greater than 1. The elasticity of demand will be greater than 1. And they told that when the price is 0, the elasticity of demand is 0. Okay, when the quantity is 0, okay, when the quantity is 0, the elasticity of demand is infinity. It is undefined. Okay, guys. So these are the 1, 2, 3, 4, 5. 5 conditions you need to satisfy. So, how will you arrive at these different points of elasticity of demand along a linear demand curve? So, with a graph, okay, the understanding will not be better, guys. Okay, so let us take the example of numerical examples and apply the numericals and prove these 5 conditions. And prove these 5 conditions. As here, I have taken a numerical example. Okay, I have taken the x-axis as quantity and y-axis as price. Okay, so imagine these are the number of chocolates given to you. Okay, 100, 200, 300, 400, 500, and 600, and these are the price at dollars. Okay, so these are dollars. So for $2, okay, for $2 we are demanding 100 chocolates. Okay, for $1.5 we are demanding 200 chocolates. For $1 you are demanding 300 chocolates. For 0.5 you are demanding 400 chocolates. So we can have a demand curve. So it's here the maximum limit function A. Okay, the maximum limit function A, let us consider as 600. Okay, let us consider as 600. When the price is 0, when I will tell, I will give the chocolates for free to you. Okay, it doesn't cost any price. You will only consume 600 chocolates. So I will tell, sir, for me 600 chocolates is enough. I can't eat more than 600 chocolates. Okay, so 600 is a maximum limit function. So A is 600. So they are telling this point as A divided by B. Okay, I specified in the linear demand graph. Okay, linear demand graph, the highest point as A divided by B. So we have to find out what is B first. Okay, let us not consider that minus B. Okay, as we use elasticity of demand, a module for elasticity of demand. So B is nothing but delta Q divided by delta P. Okay, delta Q divided by delta P. So here guys, the change in quantity. So here the change in quantity from 100 to 200 was 100. Okay, from 100 to 200 was 100. And here the change in price. Okay, the change in price was from 2 to 1.5 is 0.5. So it is minus 0.5. We are not considering minus. So let us take 0.5. So B is nothing but 200. So B is nothing but 200. So when I take this A divided by B, I know what is A, I know what is B. So A divided by B will be 600 is A, okay, B is 200, which is nothing but 3. Okay, which is nothing but 3, which is exactly this point. So what does it mean, guys? What does that 3 mean? Okay, when you are demanding 0 chocolates, okay, when the quantity is 0, the price is 3. Okay, when the quantity is 0, the price is 3. So now, the first condition is to satisfy that. Okay, when P equals 0, when P equals 0, so the elasticity of demand will also be equal to 0. So this was our first condition. The elasticity of demand is also equal to 0. So as here we know that the elasticity of demand equation is minus dP divided by A minus B. Okay, the module of elasticity of demand is minus Bp divided by A minus Bp. So understood that A is 600 and B is 200. Right? B is the change in quantity divided by change in price is 200. If I substitute this, so equals minus of B is 200. 200, they're telling when price is 0, elasticity of demand is 0. So 200 into 0, if you substitute price as 0, A is 600. Okay, A is 600 minus B is how much, guys? 200. Okay, 200 into price is also 0. Okay, into 0. So here minus of 200 into 0 is 0. So 600 minus 200 into 0 is also 0. 600 minus 0 is 600. Okay, anything when the 0 is in numerator and 600 is in denominator, the actual value is also 0. So we proved that elasticity, the module of elasticity, here it was a minus sign, as it is a module we are not considering minus sign, elasticity of demand is 0. We proved this condition. We proved this condition. Is getting my point? Please try to solve along with me. Okay, please try to solve. Have a book and a pen, and please try to solve along with me. So the first condition was satisfied that when the price is 0, the elasticity of demand is 0 at this point. So this was our first condition. So students, the next condition was when Q equals 0, the elasticity of demand is infinity. The elasticity of demand is infinity. So here we add the equation that elasticity of demand equals minus Vp divided by A minus Vp. So you need to substitute Q value. Okay, when Q is 0, they're telling when Q is 0, elasticity of demand is infinity. You understood that Q is 0, the price is 3. Okay, at this point, the elasticity of demand is infinity. So we have to satisfy this condition. So here, minus Bp divided by A minus Bp, this A minus Bp can be written as Q. Right, Q equals A minus Bp, now substitute it as Q. So here, minus, let us keep it aside. So B is 200 and P is 3. Okay, P is 3 at this point. You know when Q is 0, P is 3. Okay, when Q is 0, P is 3, which is nothing but here elasticity of demand equals 200 into 3, it is 600 minus 600 divided by 0. Elasticity of demand equals 600 divided by 0. When we apply a module, so it becomes positive, it is 600 divided by 0. We can tell it as undefined. So 600 divided by 0. Guys, why will you call it as 600 divided by 0 as undefined? Okay, so guys, here if there is 6 chocolates, okay, if there is 6 chocolates, I want to distribute it to 2 of them. So I will do 6 divided by 2. I will do 6 divided by 2. So both the 2 will get 3 of the chocolates. Okay, you both, example, there are 2 students, they will tell, sir, I want chocolates. So I have 6 chocolates, I have to divide among them, so I will do 6 divided by 2, which is 3. So here, if it was 6 divided by 0, I can't divide to anyone. I can't divide it to anyone. So it is called as undefined. So it is called as undefined. Okay, in your school classes you have learnt, so 6 anything divided by 0 will be undefined, which is infinite. It can be called as infinite. As getting my point? So we proved that elasticity of demand when Q equals 0 is infinite. Okay, we satisfied these 2 conditions. So guys, the next condition is when P equals, when P equals A divided by 2B, the elasticity of demand is equal to 1. The elasticity of demand is equal to 1. Now, as we are understanding through the numerical examples, you understood this 3 is A minus B, and you need to understand at which price the A divided by 2B is lying. The A divided by 2B is lying. Okay, if I substitute A divided by 2B, which is nothing but A is 600. So 2 into B, which is nothing but B is 200. Okay guys, so 600 divided by 400 is nothing but 1.5. Okay, it's nothing but 1.5. Guys, please solve along with me. So this point can be called as A divided by 2B. So this 1.5 can be called as A divided by 2B. Well, students, we understood that A divided by 2B is 1.5, which is nothing but price. So that telling when P equals A divided by 2B, elasticity of demand should be equal to 1. So I took again the equation of elasticity of demand, that is minus Bp divided A minus Bp. So B I substitute, it is 200, you know that B is 200, price is 1.5, again divided by A is 600 minus B is 200 into price, that is 1.5. So if I multiply 200 into 1.5, I arrived at 300. Okay, so 600 later, keep it like that only, and 200 into 1.5 again is 300. So 300 divided by 600 minus 300. So this 600 divided minus 300, which is nothing but again 300. So we'll arrive at 300 divided by 300. We'll cancel completely. Using the model, we proved that elasticity of demand is equal to 1. Again, we proved this condition. Okay, this was the second condition we proved. At this point, okay, elasticity of demand is equal to 1. Guys, getting my point? So students, here we satisfied three conditions that when price is 0, elasticity of demand is equal to 0. When quantity is 0, elasticity of demand is infinity. And when price is A by 2B, that is 1.5, elasticity of demand is equal to 1. Okay, so the next condition is when price is greater than 0 and lesser than A divided by 2B, elasticity of demand will be less than 1. You need to prove that elasticity of demand is less than 1. Okay, so where does that point lie, guys? It should be more than 0. The price should be more than 0 and less than A divided by 2B. So I can tell A divided by 2B, next point is A divided by 3B. A divided by 3B. So A divided by 2B and A divided by 3B. So A divided by 3B is nothing but A is 600. Okay, 3 into B is 200. Again, 600 divided by 600 is equal to 1. Okay, at this point is equal to 1 at this point, which is when the price is 1, it is A divided by 3B. You need to prove that when price is more than 0 and less than A divided by 2B, which is A divided by 3B, which is equal to 1, we need to prove that elasticity of demand is lesser than 1 at this point when price is 1. Whereas here the condition is when the price is greater than 0 and less than A divided by 2B. Okay, we conclude that it is A divided by 3B, which is nothing but 1, which is the price. So again, we need to satisfy that in this price point, the elasticity of demand should be lesser than 1. Okay, so I use the same equation. Elasticity of demand is equals to minus Bp divided by A minus Bp. That is minus, I will keep it aside. So B is 200, the price is 1. Okay, the price is 1, I substituted 1 divided by A is the maximum limit function, that is 600 minus 200 is B. Again I will multiply it by 1 because it is P. So I arrived at 200 into 1 is 200, 600 minus 200 into 1 is 600 minus 200. So I arrive at 200 minus divided by 600 minus 200 is 400. Okay, which is nothing but using the module of elasticity of demand, which is equal to 0.5, which is lesser than 1. We again proved this condition. Is getting my point? So we proved another condition named elasticity of demand is lesser than 1 when price is 1. Okay, when the price is more than 0 or less than A divided by 2B. Or less than A divided by 2B. The next condition is when price is greater than A divided by 2B, okay, when price is greater than A divided by 2B, the elasticity of demand should be greater than 1. The elasticity of demand should be greater than 1. So, the price which is greater than A divided by 2B, that is 1.5, is 2. Okay, is 2. So, it is greater than A divided by 2B. So, I can take price equals to, I can take price equals. So students, here I took the price as 2, okay, and you know that again I use the equation, that is elasticity of demand equals minus BP divided by A minus BP. So here elasticity of demand equals B is 200, the price was taken as 2, which is greater than A divided by 2B, divided by A is 600 minus 200 is the change in quantity divided by change in price, that is B, the slope of the demand curve, into 2 is the price taken. So it becomes 200 into 2, 400, 600 minus again 200 into 2 is 400. So 400 divided by 600 minus 400, which is nothing but 200. So you arrived at minus 2 using the module of elasticity of demand. It is elasticity of demand equals to, which is greater than 1, which is greater than 1. We also proved this condition. So elasticity of demand is greater than 1. So when the price is 2, the elasticity of demand is greater than 1. As understood? So these are the different elasticity points along a linear demand curve. Okay, I told you the elasticity, the points of elasticity will be different among the different prices. So we proved that when price is 0, elasticity of demand is equal to 0 at this point. Okay. And when quantity is 0, elasticity of demand is infinity, and when price is A divided by 2B, elasticity of demand is actually equal to 1, and when the price is more than 0 and less than 1.5 at the price 1, the elasticity of demand is lesser than 1, and when the price is more than A divided by 2B, that is more than 1.5, that is 2, elasticity of demand is greater than 1. So these are the 5 conditions we satisfied, guys. Okay, here for 300 I can also write as A divided by 2. Okay, at this point A divided by 2, which is nothing but 600 divided by 2, which equals 300. Okay, guys, this is all about the elasticity along a linear demand curve. Okay, how did we use the demand curve equation and determine the different points of elasticity along a linear demand curve? Okay, along a linear demand curve. Okay, so let us end our session here, guys. In the next session, we shall discuss about constant elasticity of demand. Okay, guys, thank you.